Good morning, good afternoon, good evening. Hello, and welcome to this C++ Builder 10.2 Tokyo Release 2 What's New web meeting. My name is Al Manarino, and I'm one of the Embarcadero software consultants. So C++ Builder 10.2.2 has many new features, as we see here on this slide. So during this web meeting, we'll look at these what's new features in the current C++ Builder 10.2.2 release. So specifically, we'll look at these items in bold text. So we'll look at the new FireMonkey quick edit support. We'll look at the 4 new VCL controls. We'll look at C++ multi-device support that's been in the product for many releases now. We'll take a quick look at the new dark themed IDE option, and that's designed for nighttime work and for any developer who prefers working with dark styled applications. This next item we're pretty excited about. The RadServer single site with multi-tenancy support deployment license is now included in the Enterprise and the Architect editions of C++ Builder 10.2.2. We'll look at some new C++ enhancements for performance in this current Tokyo 10.2.2, and we'll compare the performance of the Borland Classic compiler with the new enhanced-Clang compiler. We'll also discuss the new installer and look at the new welcome page enhancements. And lastly, we'll take a look at some of the C++ 11 support and modern C++ support that we have in C++ Builder. And we'll definitely leave some questions at the end for any questions you may have. During the presentation, if a question comes up, just feel free to shout it out, because I don't think anybody's on mute, so you should be able to speak freely. Okay, so now we should all be looking at Rad Studio 10.2.2. So as a start, we should all know by now that C++ Builder is a standard C++ application development platform for Windows, Mac OS X desktop, mobile, iOS, and Android, and the Internet of Things. So here in the IDE, we see a C++ Builder multi-device application that uses the location sensor on the device to get our location, latitude and longitude, and then we pass the latitude and longitude to maps.google.com, and then we display our location on a map inside an embedded web browser on the device. So C++ Builder is a modern C++ product, standards compliant, with enhanced language extensions. So as we see in this design view, C++ Builder includes this very beautiful native user interface tools, and C++ Builder gives us cross-compilation to, if we look at the project manager here, we can cross-compile to Windows 32-bit, Windows 64-bit, Android, iOS 32-bit, iOS 64-bit, and the Mac OS X desktop, all from the same user interface and all from the same single C++ code base. So for example, if I was to highlight Mac OS X desktop, and we can look at the view for what this app would look like on a Mac OS X desktop, and if I go ahead and build it and run it, it will build it for a Mac OS X desktop, create the Mac OS X desktop binary, and after it creates it, it will deploy it directly to my Mac and run on the Mac. So here's the application running on my Mac. So since my Mac does have a location sensor, I can activate it, and we're first prompted, do I want my Mac to know where I am? I'll say okay. So now we're sending latitude and longitude to maps.google.com, and on the bottom here we have our web browser that will display our map of our current location. So here I am in New York on Long Island in a town called Carr Place. So all of this works fine. So as we can see here, create the application once, user interface once with the same C++ code base and be able to deploy it across those multiple devices, Windows, iOS, Mac OS X, and Android, all from the same code base. So hopefully by now you can see that C++ Builder provides the full stack for native app development, from databases to native apps, with this nice flexible user interface, including great REST APIs and so much more. So likewise, I could also have selected Android and targeted Android and send this directly to my Google Nexus 7 tablet. So any questions before I continue on C++ Builder's multi-device capabilities? Let's take a look at a few of C++ Builder's new features for the VCL, Visual Component Library, and for FireMonkey FMX. So starting in 10.2.2, if I create a new multi-device FireMonkey C++ application, let's pick a tabbed application. So this will create a FireMonkey form, and because it's not the default form, it asks me to save this project in a folder. So I'll create a new folder. I'll call it my FMX inventory app. So because we selected tabbed application, it should display a FireMonkey tabbed application. I think four tabs to start with, as we see here. So I mentioned I'm going to show you the new FireMonkey quick edit option. So VCL already has this option, but now we also added it to FireMonkey. So what I mean by quick edit option is if you select the form or select any control and you right click, for example, right now I selected the toolbar label and I right clicked and I'll select quick edit. You are prompted with the most popular properties that most folks want to make changes to for this control or for this form. So right now I can change the name of the toolbar, or I can change its text. So I'm going to change its text. This will become my inventory control app. And you can also change the alignment and the layout of the control or the form also from this quick edit menu. So as we see here by the quick edit, I was able to change the text of the toolbar. So instead of the productivity advantage here is, instead of having to go from the form to the object inspector to make the changes, I can stay in the form, right click, quick edit. So for example, instead of having to go to object inspector and type the text in here, I can do it from the quick edit menu as we just did here. And likewise, I can select tab number 1, right click, quick edit. Maybe this will be my login tab for my application. Change this text. So that works fine. So let's say this is going to be our login tab for our inventory control system. So right now I'm on the tab control, and similar how you would drag and drop components from the tool palette onto the form, we can do the same here. So I can select the label, add it onto the form, and likewise using quick edit, right click on the control, quick edit. Maybe this will be my username. Well, maybe I'll call it my label for username, and the text here will be, to enter my username. So that works fine. And likewise, I'll add an edit box. I'll right click, quick edit. Maybe I'll call this my edit for the username, and the text will be blank. So you get the idea how quick edit works. Right click on a form, right click on a control, and be able to quickly change the common properties of that form or that control right from the designer without having to go back and forth between the object inspector and the form. And because this is going to be my login screen, just to be complete, let me just spend another few seconds here and I'll copy the username label. And this will become my password label. So I'll right click on here, quick edit. This will be my password. And maybe I'll change the name to label password. And likewise, lastly, for the edit box, we'll copy it, paste it onto the form. Right click, quick edit, make this my edit for my password, and text can be blank. And because it will be a password field, we'll tell the object inspector that the password property is true, so it will not display the password. And then for completeness, we'll just drop a button on here. Right click, quick edit. This will be my button to log in, and maybe the text on the button will just say login. All right, so hopefully this gives you a feel for what you can do with the FireMonkey quick edit support. So to me, this improves my developer productivity by allowing me to quickly perform common actions in the FireMonkey form designer. So this functionality matches the VCL quick edit feature that we introduced in the Berlin 10.1 release. All right, any questions on this before I continue? So this was a quick look at the new FireMonkey quick edit support. So next, let's look at some of the new VCL controls in C++ Builder 10.2.2. So 10.2 Release 2 introduces 4 new VCL controls. The first one's called a card panel. So you can drop a card panel control onto your form, and CardPanel is a specialized panel component that manages a collection of cards. So as we see here, only one card is active visible at a time, and each card is a container for other controls. So this new control has support for left and right gestures, allowing you to swipe between cards. So for example, I can swipe right to left to advance the cards, or swipe left to right to go backwards through the cards. You can easily add new cards, or you can remove the border from the card right from the right click menu in the structure pane. And you can also loop between all of the cards in a collection to customize the look and feel. And then you can also customize the look and feel of the application because it fully supports a VCL styling. So if I run this application, we'll see what it looks like. So this is the new card panel control. So for example, if I'm swiping from right to left, we see it will advance to the next card. So for most of these cards, I have an image component on it to display an image. But on the last card, I have a panel with a few controls. So what's nice about this is drop a card panel onto a form, add as many cards as you need, and then automatically have the left and right gesture controls available to you, either from swiping with a mouse, or if you deploy this to an application that supports touch gestures, you can swipe with your finger right to left or left to right, and that will move the cards forwards and backwards. And as I mentioned, this control also fully supports VCL styling. So if you don't like the default Windows style, You can always change it to one of the 24 or so VCL styles that we provide for you. For example, I can switch this to Windows 10 Blue. So there we go. So I switched it to Windows 10 Blue, or maybe you like Windows 10 Purple. So all of those VCL styles work with the CardPanel control. And we could either use the buttons to advance next or previous card, or swipe back and forth. That was the new CardPanel component. And you could think of it as a page control without any tabs, or an easy way to create a wizard style user interface. The next VCL control we added, and all of these samples you can find from opening a sample project under Object Pascal VCL. The next control we're going to look at is a control called StackPanel. So here in this VCL form, we dropped a StackPanel control. And a StackPanel is a new container control, allowing you to automatically align all parented controls, either vertically or horizontally, while retaining each control's custom height and width settings. So for each selected orientation, whether vertical or horizontal, you can choose how you want to position these controls that are on the panel. So if I run this application, you'll see that StackPanel has properties like orientation for either vertical or horizontal. So right now we have the StackPanel orientation set to vertical. So all the controls that are in the panel are aligned vertical. If I change the property to horizontal, we'll see the controls automatically move to a horizontal position. And then all the controls that are in the panel, you can decide where you want them positioned. So for example, they could all be on the top, or they could all be on the bottom, or you can have them centered, or you can have them fill the entire panel space. And then you can even override the positions of each of the individual controls. So for example, if you wanted the label to be on the top, you can do that. If you wanted the edit box to be on the bottom, you can do that. Maybe the button will keep in the center, and maybe we want the memo to fill the whole space. All right, so that's the StackPanel component. So as we can see here, the controls get aligned to fit within the available StackPanel space, with respecting the defined margins and the paddings that you have on the control. All right, the next two controls we'll look at are the new date and time pickers that follow the Windows 10 style for a date and a time picker. And again, for any of these examples, you can go to Open a Sample Project, Object Pascal, VCL. You'll see date time pickers here. So if you ever ran any Windows 10 applications, this is the new date and time picker you will see on Windows 10 applications. But the good news is the same date and time picker will also work on Windows 8 and Windows 7 without having to make any changes. So we dropped a date time picker on the VCL form, and we dropped a time picker control on the form. And if we run the application and we select the date, we'll see that we have this nice new modern date picker control that has support for the Gregorian calendar, and you get multiple date options for how you want to format the date. So if I want to select it for today's date, which is January 31st, 2018, check mark to select it. And then, as I mentioned, you have multiple date formats for both the date and the time. Right now it's single month, single day, year. But I can change it to any of these other date formats. For example, DD, and year. And same for the date, same for the time. So for the time, I can change it to my current time, which is 11:28 a.m. and select it. And likewise, we can change the time format for the date also. Add the seconds. And likewise, all of these new VCL controls also support VCL styling. So you can apply VCL styling to all of these controls. Let's pick Windows 10 purple and get the nice Windows 10 purple style. So what's nice about this, by adding styles, you can modernize the look and feel of your VCL applications without having to do any coding and make the application look much more modern just by adding a VCL style to the application. So I mentioned that these controls were designed for Windows 10, but they will also work on the older versions of Windows, such as Windows 7 and Windows 8. And as we see here, they fully support custom VCL styling. All right, so as I've been running these applications, hopefully you're seeing the new updated IDE look and feel with all of the new components that we added. So for example, the new welcome page is laid out as we see here. So in addition to the getting started sections, you have a develop section, you have a expand and extend to get to the get it package manager and the platform manager, your favorite projects up on top, your recently opened projects in the middle, and the sample applications that we ship with the IDE are in this bottom area. We also include upcoming events and YouTube videos to help you get trained on how to use the product. And then if you haven't noticed yet, all of the component icons have been modified with a new modern style to complement both the light theme IDE that we're looking at now, and we also added a dark theme to the IDE. So right now we're looking at the light theme, but let's say you prefer to work with a dark theme style. Up on the top toolbar here, this little moon symbol here, you can switch between the light themed IDE look or the dark themed IDE look. So if I switch the IDE to the dark themed, you'll see it now changes to a different look and feel for a dark theme. So this dark theme was designed for nighttime work and for any developer who prefers working with dark styled applications. So this is a common productivity feature for developers who like to work in the evening. So you can easily toggle between the dark theme and the light theme. And for example, we're in the dark theme now, and you'll see that the icons for each of the controls corresponds to the theme you're working in. So right now I'm in the dark theme, and you see that these components, they represent these nice new modern, bold, and vibrant styles based on the theme you're running. And then we complemented the light and the dark theme with editor options. So for example, if I switch to the coding tab, you have a choice of different types of editor options. So right now the dark theme default editor option is Twilight, but you can also change it to any of these other editor backgrounds that you prefer to work with. So that was a quick look at the new dark theme that we've added to the IDE. So since I'm developing in the daylight now, I'll switch back to the light theme. All right, so any questions on any of this so far? So we have added many C++ Builder enhancements to this current C++ Builder 10.2.2, like we see on the slide. So for example, the linker is now large address aware, so you should not see any linker errors due to out of memory. We greatly improved the compiled C++ performance, debugging, and large memory support for the linker. The Clang enhanced Windows 32 and Windows 64-bit compilers now have a strong optimization level, which you will see may double the compiled code performance in many situations. You have better code gen in the Clang enhanced compilers. The Clang enhanced Windows 32-bit compiler now generates debug info, so it did not do that before. And for mobile multi-device support, packages for iOS and Android are now built with the .a extension instead of the shared object extension that it used to build before. And if you're creating any multi-device Android applications inside of C++ Builder, they can now be built without requiring a specific version of the NDK. And then in addition, many quality fixes for exception handling and for debugging were added to C++ Builder 10.2.2. So for example, for performance, if you compare a Windows 32-bit app using the classic Borland compiler, the BCC32, compared with using the new enhanced-Clang compiler, the BCC32C, you may see twice as fast performance. So let's take a look at a classic compiler versus a Clang compiler performance example. So let me go back into the IDE. Okay, so here we have a classic compiler application that performs mat, sort, and shuffle operations. So here I do some mat operations. So here I'm randomly creating 100,000 random numbers and adding them to a standard vector, and then we perform 500 mat operations to calculate the square roots of those randomly generated numbers. And then finally, we're doing another 200 random shuffles on the vector. So it's an example that stresses mat, sort, and shuffle operations. So if I first start with the classic Borland compiler, so if you don't know by now, in C++ Builder we include both the classic Borland compiler, as we call it, and we also include the enhanced-Clang compiler. So let's first run this application using the classic Borland compiler. And for that, just to verify we're using the classic Borland compiler, we can go to Project, Options, C++ compiler. There's a node called Classic Compiler. So it says use the classic Borland compiler. So if we set that to true, then it will build the application with the BCC32 compiler that most of you are familiar with. So I'm going to run this application using the classic Borland compiler. So here's the application running using the classic Borland compiler to do mat, sort, and shuffle operations. So we see it took about 1 second to do the mat operations, another 5 seconds, let's say, to do the sort and the shuffle, for a total of 6 seconds. So now let's run the same application using the enhanced-Clang compiler. So it's the same source code. Let me clean it so it doesn't have any of the Borland compiler objects in there. And just to make sure we're running the Clang compiler, again, I'll go to Project, Options, select the Clang compiler. So now we say use classic Borland compiler set to false. So in this case, it will not use the Borland classic compiler. Instead, it'll use the Clang compiler. So we're going to run the same application now using the Clang-based compiler. And you can tell Clang because it calls BCC32C for Clang. So now we're running with the Clang-based compiler. And if we compare the two, we can see that doing the same operations with the Clang compiler only took 3 seconds compared to the 6 seconds to do the same operations with the Borland compiler. So we see, if we look at the individual options here, so mat, 300 milliseconds with Clang, almost 800 milliseconds with the Borland compiler. Same values for sort and shuffle. Let's call it 3 seconds with the Clang compiler, almost 6 seconds with the Borland compiler. So you can see twice as fast performance using the Clang compiler versus the Borland compiler. So this was just one example on how the Clang compiler gives you better performance than the classic Borland compiler. So any questions on this? So the question I have for you folks on this meeting is, I'd like to know if anyone on this meeting is still using the classic Borland compiler and hasn't moved to the Clang tool chain yet. And if the answer is yes, I'd like to know what reasons you have for still staying on the classic Borland compiler and not moving to the Clang tool chain. So you don't have to answer it on this call, but maybe for follow-up discussion, if any of you are still using the classic Borland compiler and not yet moved to the Clang-based compiler, and you have some specific reasons for needing to do that, we'd like to know to find out what we can do to help.
Hey, Al, I have one question. When will Mac OS X 64 be available?
Yeah, that's a commonly asked question. So currently, both Rad Studio, Delphi, and C++ Builder has Mac OS X 32-bit support. So if you follow our public roadmap, our product managers believe that for the next release. So right now we're looking at Rad Studio 10.2.2. For the next release of Rad Studio, Delphi, and/or C++ Builder, which will be released 10.3. The roadmap plans, so we hope to have Mac OS X 64-bit support for the next upcoming release. So I can't speak for the product managers and the R&D folks on when that will be released. So periodically, the product managers post public roadmaps for what new features are going to be into the product. So I'll for the follow-up emails, I'll send you links for the public roadmap so you can see what we have planned for the upcoming releases of Rad Studio, Delphi, and C++ Builder. All right, thank you for that question. All right, next let's look at some modern C++ examples using C++ Builder. So the good news is that C++ Builder 10.2.2 supports the C++ 11 standard. So this is an example of using modern C++ function templates. So notice here that our function template, get max. So we see that our function template get max here does not have to explicitly specify the type between the angle bracket here. We're just calling it class T. So the good news is that the compiler will automatically determine what type is needed on each call. And because our function template includes only one template parameter, which is class T, and the function template itself accepts two parameters, A and B, both are of type T, we cannot call our function template with two objects of different types as arguments. So in this application, we're using three different types of types. We have ints, longs, and doubles. And we see by using the function template get max, we are going to determine what is the max value of two values that are provided into the function. So so I'm gonna run this application as using the Windows 32-bit Clang modern C++ compiler, and we'll just take a look at the results. So we're calling our function template get max, comparing two different values of integers, longs, and doubles. And we see here that it does return the correct values. So I mentioned because this function template uses the same type template parameter class T, we can't mix types inside of this function call. So for example, if I tried to compare an integer with a type of long, the compiler should complain that it does not know what to do with that. So that's correct. No matching function call to get max. So because it's the same single class type, the parameters that we pass into it all have to be of the same type. So now the compiler is happy and it can run. The next item I want to bring up is our RadServer product, RadServer capability. So if you have not done this yet, I think this was first introduced back in Rad Studio and C++ Builder, maybe 10.2, in the Enterprise and the Architect Edition. So if you're running an Enterprise or an Architect Edition, you should be able to open up a command window and type EMS Dev Server, and this stands for Enterprise Mobility Services Development Server. So this is our turnkey out-of-the-box REST server that we call RadServer, or sometimes you'll see it referred to as EMS for Enterprise Mobility Services. So this is a turnkey out-of-the-box REST server, and as you can see out of the box, we provide these 7 resources and all of these endpoints. So for this REST server, we allow you to access the version of the REST server you are running. There's a resource called API, which will document all of the APIs you have created into the REST server and display them in YAML format. You have access to all of the users that you have added into the REST server and all of the groups that you have added to the REST server, including being able to get all of the users or get an individual user, sign up new users, and also use this for login authentication. So for example, we can log in the user so that that tabbed application we were creating, if we wanted it to connect to this middle tier REST server, we could use the built-in login authentication methods of this EMS RAD server to do login authentication. RadServer also provides installation support. So this means installations are all of the outside devices that have connected to the REST server. We can control and manage all of the outside REST clients that have connected to the REST server. RadServer also includes built-in push notifications, so you could send push notifications to all of the connected devices. And lastly, as an out-of-the-box functionality, RadServer also provides something that we call edge services, and this has to do with Internet of Things, Bluetooth, LE devices. So you're able to collect data from Bluetooth, LE devices and store them in these edge modules, and then outside clients can connect to this RadServer and access the data inside of these edge modules, so they can see the data from these local Bluetooth, LE devices that are too far away for them to connect normally. So we give you all of this out of the box, so you don't have to write or code any of this, and then any type of front-end REST client is able to call these resources and get the information. So for example, it could be as simple as a web browser. So if I just open up a plain web browser, so by default we call the version endpoint. So all the REST client needs to know is the IP address and the port of where the REST server is running, and then they can call the endpoint or the resource. In this case, we called version, and what gets returned back is this JSON object from the REST server. So JSON name value pair. So the name version, the value 3, the name server, and the value EMS, Embarcadero EMS. So likewise, there was a resource called users. So if I call the users endpoint, it will return back all of the users that I have entered into my REST server. So here we have a user called manager1, waitstaff1, and there's a nurse user that we have entered on there. And likewise, there was an endpoint called groups. So we see on our REST server, we have 2 groups, one group called managers and one group called waitstaff. So this is all pre-built out of the box. So again, you don't have to spend or waste any time trying to build one of these yourself. We already built it for you. And then what you do is you extend this RadServer EMS server with your own existing C++ builder functions and methods and data access routines, and you put them inside of this RadServer, and then this RadServer will automatically expose them out as manageable REST endpoints that any type of REST client can call and access. So let's take a look at that. So when you look at the different types of file types, if we go to File, New, Other, under C++ Builder, you'll see there's a new node called EMS. So you'll have the option of creating a new EMS package, and then after you create an EMS package, you'll be able to create one or more EMS modules to put in the EMS package. So what that looks like is this. So here's a C++ Builder EMS package that we created, and inside of this EMS package, we created an EMS resource that looks like this. So in this case, this EMS resource is a data module that knows how to connect to a backend database and get data. So here we're using the FireDAC connection. So this FireDAC connection knows to connect to a backend SQLite database, and we can use this FireDAC connection editor to test to make sure we can connect. So we can connect, okay, that's fine. So this database module knows how to get data from the customer table and from the orders table. So if we look at the customers table, we can use this FireDAC query editor to test to make sure that we can return customer data back. And likewise, we're going to go after the orders table, and we see orders comes back. So what we've done here is we've taken one of our existing data modules and we've dropped it inside of this EMS module. So now we can reuse this data module that knows how to connect to customer and order data. So think of this as your standard master detail type of application where I want to select all of my customers and see all of the orders from my customers. And then inside this EMS module, you give the EMS module a name. In this case, we called it test. So test knows how to do things like get data from the backend database, and it knows how to post updates for any changes we make to the data that gets returned. So just like you would write any VCL or FireMonkey application to connect to a backend data source, this is the same code you would put inside of one of these EMS modules. So for example, when we call the get endpoint of this module, it will open up the customer query, it will open up the order query, and since we're using FireDAC, FireDAC has a wonderful method called FireDAC schema adapter that knows how to map the columns of the data to the data being returned. So we can call FireDAC schema adapters save to stream and save all of the returning data in JSON format, name value pair, and then we could send that data back to the calling REST client. So the client will get this return stream of JSON objects or JSON arrays, and then we can test this, from a web browser. So I'm going to highlight the EMS package and run it. So this will run our RadServer EMS REST server. So now we see, in addition to the 7 pre-built out-of-the-box resources that we provide, there's now a new resource called test that knows how to get data from the database and knows how to post changes back to the database. So to test this, again, any type of REST client, including a simple web browser, we can call this test endpoint and check that data gets returned. So now I'm going to call the test endpoint, which will call the get, which will connect to the backend database and bring back all of our customers and all of their orders. So this is a large JSON array that gets returned, and any type of REST client knows how to parse those JSON arrays or JSON objects and display it nicely on a client. So for example, we can create a C++ Builder VCL client that looks like this, or a FireMonkey client that looks like this, where I drop the database grid on the top to display all the customer data, and we have another database grid on the bottom to display the orders from those customers. And to connect to that middle tier layer, we simply need to drop a EMS provider component on the form and just give it the IP address and the port of where that RadServer is running. And then we can drop an EMS Fire.Client component on the form and just tell it the endpoint to call. In this case, it's test. So now when I run the client application, so this is what we're looking at here. We have our EMS or our RadServer running. Right now it's running standalone on my Windows box, but this could be hosted in a Microsoft IIS container, or it can be hosted in an Apache web browser, or it can be created as a Linux binary, or it could be hosted up in a cloud service somewhere. So as we see here, we have an outside REST client running. When I click on this Get Tables button, we'll see that it sends the resource test to the RadServer, which calls the get endpoint, which returns back that JSON array of all of my customers and all of my orders. And because of the FireDAC connection between the one-to-many relationship of customers and orders, it knows to display the customers in the top grid, and it knows to display the orders in the bottom grid. And again, because of the relationship, if I select any customer from the top grid, it knows to automatically update the orders on the bottom for that individual customer. So for each customer I select, you'll see the orders that go with that customer. So that's a nice ability of FireDAC to be able to do this. So right now we see the post updates button is grayed out, but if I make any changes to any of the data in any of these grids, we'll see that the post update button gets active. So I made a change to this one customer here, Anna. So if I click the post updates button, we'll see that test resource again gets sent to the REST server, but this time we're going to call the post endpoint that knows how to apply all the changes to the database, back to the database, and make this change to this customer contact name I just made. So this is one way of how you can use this RadServer EMS server. And the good news is now this RadServer single site license is now included in the Enterprise Edition or the Architect Edition of C++ Builder 10.2.2. So you can deploy a RadServer single-site, multi-tenancy supported RadServer with unlimited users that's now included with C++ Builder. Because before this usually came with a $5,000 deployment license to be able to do this. But now it's included free of charge to allow you to deploy a single site instance of this RadServer EMS REST server to a single site with multi-tenancy support. So any questions on any of this? Okay. So the key takeaway here was when you create these RadServer EMS modules, you can reuse all of your existing C++ Builder functions and methods and data access routines and drop them into this RadServer EMS server, and then EMS or RadServer will automatically expose them out as these manageable REST endpoints that any type of front-end REST client can call to access these functions, access these methods, access these data module routines, and a JSON array or a JSON object will get returned back to the calling client. So very powerful feature of what RadServer EMS server can do. Let me return back to where I started. So hopefully you've seen that C++ Builder supports modern C++, and C++ Builder is a standards compliant IDE with our own enhanced language extensions. And C++ Builder has this very beautiful native user interface design panel here that will allow you to create these nice native cross compilation multi-device applications that can be deployed to Windows 32-bit, Windows 64-bit, Android, iOS 32-bit, iOS 64-bit, and the Mac OS X desktop, all from the same user interface and all from the same single C++ code base. This ends what I had planned to show you for what's new in C++ Builder 10.2.2 Tokyo. Here are some additional resources to give you additional details on what's new in Rad Studio 10.2.2 from this doc wiki link. You can also get a list of C++ and the debugger improvements from this community site article. You can get a list of new features and fixes in Rad Studio 10.2 Tokyo Release 2 from this EDN article. And lastly, specifically for C++ Builder 10.2.2, to get a list of what's new, you can visit this doc wiki link here. Thank you all for attending this What's New in C++ Builder 10.2.2 web presentation. Any questions you have, you can send directly to me at al.manarino@embarcadero.com. Thank you again, and have a great day.